All right, in this lesson, today's lesson, we're going to transform exponential functions. And we want to use your pink notes. So we're on the back of your pink notes and we're looking at the exponential function specifically. So let's look at this guy. Look at it. It's y equals b to the x. Now b can be any number besides 1. 1 to the first power, or 1 to any power is still 1, so that's not very interesting. But b can be any number. Now for the sake of example, we're just going to make it a 2. Keep it small and simple. So y is going to equal 2 to the x. That's what we're going to use as our parent function. But notice this, that x, the unknown, is in the exponent. That's where we're getting the name exponential. Now you did do these back in Algebra 1 days, but I want to remind you what those points look like. So like if we do an xy table, if x is 0, if we put a 0 in for x, anything to the 0 power, if you remember, is just a 1. If you put a 1 in here, 2 to the first power is a 2. If you put a 2 in for x, 2 squared is a 4. And if we go to the negative side of things, if you put in a -1, remember what a negative exponent does? Remember that just means it makes it 1/2. And then if I keep on going, if I went 2 to the -2, that'd be just 1/4. So those fractions are going to get smaller and smaller and smaller. So what's going to happen is we are going to have an asymptote this time. And as we plot these points, so let's zoom in and we plot these points. So we have it at 0, 1, 1, 2, 2, 4. And over here, it's going to be like 1/2. And it's going to be approaching our x-axis, but it's our asymptote. So when you do an asymptote, you need it to be a good, thick, dotted line that's visible to the eye, okay? And you want to notice that this line is making this shape. It's approaching the asymptote, but it won't cross it. It won't ever cross. That can't happen. Now, if we go back and look at this, and let's talk about domain. Now, look at the domain. Isn't it going it's going far left, and it's going to continue far right. So it's all real numbers. So let's do both notations for fun. So x such that x is an element of all real numbers. Interval notation, that would be -infinity to +infinity. Now the range is limited because of the asymptote. So when I do the set notation, I have to pay attention to where is y happening. Well, it's right above 0. It's not including that 0 because that asymptote nothing can touch, but it's right above it. So we're going to say greater than 0. So be careful that you don't put the or equal to, because equal to would mean that the asymptote really doesn't exist. It can equal 0. Well, it can't. It's greater than 0. And then in interval notation, we would say 0 to +infinity, and I would want to make sure I put a parenthesis on that 0 because it's not a hard bracket. It can't equal 0, but then goes to +infinity. Now, since it never crosses this asymptote, it never crosses the x-axis, so there is no x-intercept. Now, the y-intercept is right here at 0, 1, where it crosses that y-axis. And then there is an asymptote. Since it's a horizontal line, it's y equals 0. So these are the traits that you're going to want to have on your pink notes. Now, you notice I made a little sticky note here that we're going to use as we transform these on the future graphs on your homework. So let's transition to that page. All right, in today's lesson, we're going to just continue transforming exponential functions. So let's look at our instructions here. It says to state the transformations with regard to the parent function of y equals 2x. Remember I told you we're going to use the base of 2 as our parent function. Now you may see other things in the future, but right now we're just going to graph with the base of 2. Then it says graph the function. So state the transformations, graph the function, don't forget the asymptote, and state the domain and range using interval notation. Remember, interval notation is the one with the parentheses and the infinities. So let's do one thing at a time. Let's just go through and state the transformations. So look at this one right here. Number 1. Now, get used to this. This 2 to the x is just the parent function, and so the -2 is hanging off the x part. That means it's like it's in the parentheses. So anything happening to the x, remember, is opposite of logic. So it is going to be moving. So this one then would be moving right 2 units. And that's all that's going to happen there. Let's look at number 2. Remember, this 2 to the x part is just part of the parent function, so don't really look at this. Look at what's happening to it. This is moving us down 5. Number 3, now that there's 2 to the x, that's the parent function, but then the leading negative makes it a vertical reflection. Let's jump over to number 4. Now, the 2 to the x is here, so this is like it's being multiplied on the outside. So that is a vertical stretch by 3, and that minus 7 means it's going down 7. Look at number 5. Got more things going on. There's a negative, that means it's a vertical reflection. The x minus 1, remember it's going to go opposite logic, so it's going to move right 1, and the plus 3 means it's going to move up 3. And then last but not least, there is a fraction here, so that's a vertical shrink by 1/4. 2 to the x is just the parent, so ignore that. And the minus 1 means it's going down 1. Okay, now let's go back and graph some of these. Now, all right, so we're moving we're moving our origin right 2. So I'm going to take it over here, and I'm going to put a little plus sign because that's my new origin. And the first thing you want to do is remember that the horizontal asymptote that goes through the origin. So it's still right through here, so we're going to place that there. Now, if you recall, we had our parent points, right? So here's my parent points that we're going to use to help us, from our origin, place our values, okay? So at 0, 1, and at 1, 2, at 2, 4, and then if I go to the left of my new origin, I'm just going to go to 1/2, and then I'm going to draw my curve. There it is. That's what it looks like. Let's look at number 2. This one takes our origin and moves it down 5. 1, 2, 3, 4, 5. So it moves it all the way down here, so you can put a little plus sign, and that's where your asymptote is going to fall. Okay? Then that's all that's happening other than this. Our points really are from our origin are just going to follow the example we have. So at 0, 1, at 1, 2, at 2, 4, and then at negative 1 going to be a 1/2. So there you go. Let's try number 3. This one's reflecting, so it's not changing my origin, so that asymptote is still here. So what that means is when it's reflecting, it's taking my y values and multiplying by negative 1, if you will. Okay? So at 0, it's going to be negative 1. At 1, it's going to be negative 2. At 2, it's going to be negative 4. All right? And then if I go to negative 1 for my x, it'll be at negative 1/2. So it's just kind of approach this way. Looks like it's flipped vertically. So it's flipping this direction across the x-axis. So vertical reflection. Let's try number 4. All right, 2 different things happening on this. We have a vertical stretch by 3. And we have it down 7. So this one is going to go down 7. So it's right here. Vertical stretch by 3 means I'm going to do 3 times whatever the y value is. So from the origin, I go straight up. Instead of 1, I'm going to go up 3. All right. And then if I go right 1, instead of going up 2, I'm going to go up 6. If I go right 2, instead of going up 4, I'm going to go up 3 times 4, which is 12. So it's growing very, very fast. And then if I go left 1, okay, 3 times 1/2 is 3 halves, which is 1 1/2. So it's right here. Oh, you know what? I forgot to put in my asymptote, didn't I? That is a big help. You need to have that always. So when I draw this in, look how quickly this thing grows. Very, very quickly. Now, let's look at number, what are we on, 5 now? Look at 5. This one's going to vertically reflect. It's going to go right 1 and up 3. 1, 2, 3. So my new origin's right here. So I'm going to start like you should do is put that asymptote in first. And then from there, from my new origin, I'm going to go, instead of up 1, I'm going to go down 1. And to the right, I would go down 2. And go over 2, down 3, 4, right? And then if I'm going to the left, the negative 1, if I flip that, it becomes negative 1/2. And you can see how this thing is going to turn this way. All right, last but not least, let's look at number 6 here. Vertical shrink by 1/4. So that's going to affect the vertical changes I make with my y coordinates. We'll get there. But let's first realign our origin. It's just going down 1, so it's right here. And I'm going to put my asymptote in. Make sure it's clear, make sure it's dotted, and we're good. Now, vertical shrink by 1/4. So instead of going from the 0, the y-axis, instead of going up 1, I'm going to go 1 times 1/4. So I go up only 1/4 of the way, very small amount. I go over 1, instead of going up 2, 2 times 1/4 is 1/2. Instead of going over 2, instead of going up 4, I'm going to go up a whole 1, which puts me right there. So it's very, very slow growing. If I go to the left one, okay, 1/2 of 1, think about this, 1/2 times 1/4 is 1/8. So it's barely above that asymptote. So it's very, 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 very slow growing exponential function, but it's still an exponential function. All right. Now that we've done that, let's look at some different kinds of questions here. Write the exponential function matching each description. So it says the parent function 5 to the x. This is our parent function. So remember how I told you that when we graph these, we're going to use 2 to the x? I'm never going to ask you to graph them if they're anything besides 2 to the x, okay? I promise you that. However, when it comes to writing equations, you might have a parent function that's some other base, like a 5 or a 3. All you're doing is describing and writing equations. You're not graphing it. So anytime I ask you to graph, it'll be with the base of 2, so don't worry. So let's go back to this. Now look, parent function of 5 to the x, vertically stretched by a factor of 7. That means the 7 out front. Translated down 8 units, so a -8 in the back of my equation. Reflected over the x-axis means that there's a negative out front. All right, so let's write our equation. We would have f of x equals, okay, I have a negative out front, minus, the vertical is the 7, and then I can put times 5 to the x, there's the parent, and then the -8 in the back. If you want, you can put parentheses around that if you'd like. Sometimes that helps you to see it better. But definitely don't multiply the -7 and the 5. That's not what you want to do. Look at B. The parent function is y equals 3 to the x. So this is just the parent. It is vertically stretched by a factor of 12, so that's out front. Translated 10 units up, so that's a +10 in the back. And translated right, 5 units, so that would be x minus 5 in my exponent. So let's do that. F of x equals, okay, I don't have any negatives, but I do have a 12 out front, so I need to put that 12. And then I'm going to put my parent function, 3 to the x, minus 5? That goes in the parentheses, and then the +10 goes in the back. All right, now number 8 and 9 are just asking you to describe, just describe. That's all I'm asking you to do. Use your words, okay? The parent function is 10 to the x, so don't give me any information about 10 to the x. Tell me what's happening to that. So look at number 8 here. All right, that x minus 11 is in the exponent. That means it's opposite logic, so it's going to go right 11 units. The +2 is a vertical shift. It's going to go up 2. And that's all you have to tell me. On number 9, look, here's your parent function. This is just the parent function. Nothing's changing there, but the -2 does a couple things. The negative means it's a vertical reflection, and the 2 means it's a vertical stretch by 2. All right? So this is how we transform exponential functions and write equations. So hopefully makes a little sense. Follow the pattern, follow those parent points. Get those memorized because it will really help you in the long run. Good luck, and we'll see you in class.